ATI Firth Sterling is a manufacturing company based out of Houston, Texas that produces roughly 100,000 parts annually for the oil and gas industry. With such a high volume of parts moving through the facility, there's plenty of opportunity for errors to occur. Current problems lie in the areas of quality control and part tracking. Quality control involves taking dimensional measurements of parts, which is done with calipers and hand recording the values on paper. This can lead to repeating, rounding, truncating, or missing data. As for part tracking, 2 barcodes per order must be manually scanned by operators. This can be easily overlooked and forgotten, which makes it necessary to spend extra time accounting for the missing scans.
This shows the typical steps taken by a worker performing quality control. In this case, the worker didn't scan, leaving the part location unknown. This requires managers to spend approximately 30 hours per week to make the necessary corrections. In addition to the potential for error, handwriting quality control data requires workers to recognize any quality issues, then stop what they are doing to find a manager.
In order to address these issues, we recommend installing an RFID system and computer interfacing measurement devices. Now, an RFID system consists of 3 major parts. We have our passive RFID tags, our RFID antenna, and our RFID reader. Now, the tags will be accompanied on existing paperwork that will follow our orders throughout the facility. When the tag comes within range of the antenna, the RFID reader will recognize that and send that to the software. For the quality control portion, we recommended the computer interfacing measurement devices. Now here's a caliper that has an SPC cable that outputs the measurement if I click this button, and it is recognized by the computer as if it was a simple keystroke. We recommend similar technology for the scales as well.
In this example, a worker approaches a typical station. As the worker passes the RFID antenna, the antenna picks up the presence of all associated tags on the cart. All this data is then sent to the computer automatically with no requirement from the worker. For the quality control portion, all that is required from the worker is to manually measure the part and press the button on the calipers. This automatically records the data and significantly increases the reliability of the quality control. In addition, managers can be notified through alerts in the software so that any time a part is outside of the tolerance bounds, the manager is notified automatically. Trend analysis can also be done without any additional user input.